Let's look at an example of an acetoacetic ester synthesis now. So in this type of problem, we're going to be adding carbon chains onto an alpha carbon. So I'm going to draw in these H's because they will be important. Now in order to get this reaction started, we have to remove one of these H's. And in the acetoacetic ester synthesis, we use something with an O-. So in this case, it's going to be methoxide. And what this is going to do is it's going to deprotonate the alpha carbon. So there's what we have at this point. Now, since we have this carbanion, we can add in a halide. And remember back from semester 1, we can do SN2 on the halide in order to add a carbon chain right here. So let's just pick a halide. Let's say that's our halide. Okay, so bromine with 3 carbons. Now in SN2, we're going to take these electrons, attack the carbon with the leaving group, and the leaving group leaves. Okay, now we have another H, so we can do this again. So we'll add in another methoxide, deprotonate this other alpha proton. Okay, now we can do the same exact thing as up here. We can add in another halide. Doesn't have to be the same one, we can pick a different one. So let's do a longer chain this time. Same SN2 reaction. Now this time we have 5 carbons. Okay. Now at this point, we can do a step that's called a decarboxylation. So this is going to essentially remove part of our structure, and that's going to be this part up here. So right now it's not a carboxylic acid, it's an ester, but we can turn that into a carboxylic acid by adding in 2 steps. So first step, we're going to add in NaOH, and the second step we add in dilute acid. Now what these reagents will do is give us carboxylic acid from our OR group. Okay, so see, we went from this ester, now it's a carboxylic acid. Now, if we add in one more thing, which is heat, we can decarboxylate. And then when we do this H right here on the OH will go in place of this carboxylic acid that we get rid of. So I'll draw that H in red so you can see where we took away our carboxylic acid, and now we just have an H. So this is our final product. Let's do a quick mechanism on acid hydrolysis. So in this type of problem, we're going to need an acid in order to hydrolyze our structure. So in the first step, we're going to take one of these electron pairs on the carbonyl, and we're going to obtain a proton from our acid. So now we have a protonated carbonyl group. And now what we can do is use the water molecule that remains to do an addition at this activated carbonyl. Okay, now at this point, something doesn't look right? So we need to take away one of these protons on this water molecule that we added, and what we can use is another molecule of water. So we deprotonate. And we end up with this molecule. Okay, now at this point, we do a reprotonation step. And what we're going to reprotonate is this carbonyl now. So we're going to use the acid molecule that we just formed back up here. Now our final step, once we have this structure, is to do an elimination. And we'll call it an E2 elimination. So what's going to happen here is we take a molecule of water, and we're going to deprotonate this H up here on the O. Now, when we deprotonate that H, it gives us a set of electrons. What's going to happen with those is they're going to come down, form a double bond between the O and the C. Now the C has too many bonds, so it has to kick one off. So it's going to kick this bond off between the C and the O. But these electrons, instead of just going on the O, form a double bond between this O and this C. Now this C has too many bonds, so it's going to kick a pair of electrons up onto that O. And then our two pieces that we get look like this. Okay, so this first piece is this part right here to the left side of that dash. So it's this carbon double bonded to the O with the CH3 and OH. Carbon double bonded to O, CH3 and OH. Now you also get the right side of this molecule, which is C double bond to O, CH3 and OH. So as you can see, we get two of the same molecules in this case, and of course the acid. And then the acronym for this reaction is Padre 2. Protonation, addition, deprotonation, reprotonation, and an E2 elimination.